Welcome to the third lecture of DLS. In last lecture, we have seen the different positions of the prism and pyramid in a space. Now, from today's lecture, we are going to see the actual problems which we are going to ask in an examination. Now, firstly, we will see the development of prism and cylinders. After that, we will complete the development of cone and the pyramid. Okay, so firstly we will complete the development of cylinder and prism only. Now the first statement, let's see the first statement. Draw the development of complete surface of a cylindrical drum. Diameter is 40 mm and height 60 mm. So this one is the first case. Now let's see the another case. Now in first case we are just keeping the cylinder on the HP and we have to draw the development of that cylinder. But now let's see the second case. In second case, let's see the statement. Draw the development of lateral surface of lower portion of cylinder of diameter 40 mm and axis 60 mm when sectioned by a plane incline at 40 degree to the HP and perpendicular to the VP and bisecting the axis. Okay, so firstly we will complete the first statement solution. Now in first lecture we already seen that the solution. Now let's see, this one is the top view and this one is the front view. Now we're already seen in a top view, the top view of a cylinder is a circle. Now I am taking the scale 1:1. Okay, so as in a statement they mention that the diameter is 40 mm, so here I am taking the diameter as 40 mm. Now take the projections of this circle up to the reference line. Okay, so here I am taking the projection of this circle up to the reference line. Now from the reference line, let's see the height of a cylinder is 60 mm. So mark the height 60 mm from the reference line. 60, 60 and join this one. So it will complete the front view. So top view is the circle and front view is the rectangle. So as I already told you that the front view of a prism is always the rectangle. Now let's see, here we have to mention the dimension. So the dimension of circle we have already mentioned 540. So dimension of this front view, the height is 60 mm. Now let's see, we have to produce the lateral development of lateral surface. So let's see, we already seen that if we cut the cylinder by vertically, so it will produce the rectangle of a dimension height by circumference of a cylinder. So here the circumference of cylinder is what? It's pi d. So it's 3.14 into d is 40. So if you make the calculation, so it becomes 125.6. so it is 125.6 mm. So as I am taking the scale 1:1, so here I am drawing the length of 12.56 centimeter. So here I am start to draw the line of 125.6 mm. So here I am giving some margin distance. So I am starting from this point. Okay, 12.56. so it is 12, 5. Okay, so 5, this is 12.56, approximately it's 12.56 approximately. So the vertical height is 6. So here mark the height 6. Now again from here mark the height 6 and simply join this one. Okay, so here you have to mention the distance. It's pi d is equal to 125.6. Okay, so this is the development of cylinder. Now we have to move to the second statement. So this is the solution of first statement. Now second case, let's see the in second case. Draw the development of lateral surface of lower portion of cylinder of a diameter 40 mm and axis 60 mm. So we have the same dimensions. This is the cylinder top view and this is the cylinder front view. Now let's see. In previous statement, we have not cutted this cylinder by any plane. Now what is the meaning of this? Let's suppose we are taking this cylinder. Okay, so this is the cylinder. Okay, so let's suppose I am cutting this cylinder by some distance from its base. Let's suppose this is the base and I am cutting this cylinder from its base by some distance, but here in statement they mention the distance is what? Bisecting the axis, means the axis is get half. Okay, now the total height is 80, so at a distance 30 mm I am cutting this one, but I am cutting this one by a plane. Let's see here, lower portion of a cylinder of diameter 40 mm and axis 60 mm when section by a plane incline at 40 degree to the HP. Okay, so here I am taking one another plane. Let's see the plane. This is the cylinder. So this is the cylinder. Here I am taking a plane. So that plane, let's see, such type of plane will cut this cylinder at an angle 40 degree. So this is an angle 40 degree. Okay, this is the angle 40 degree, and this plane will cut this cylinder in such a way that it will bisect the axis. So I am just tearing this one. Okay, so let's see, this is the remaining portion of a cylinder. This is the remaining portion of cylinder. So that profile we have to draw over here. Okay, so this is the profile of a cylinder. So it means we are cutting this cylinder by any plane and I have to draw the DLS. Now let's see, for that firstly I have to mark the axis line. Now let's see, the total length of this rectangle is 4, so its axis will lies at a distance 2. Here again it is 2 centimeter. Join this. So this is the center of the axis line. Now let's see, we have to draw the plane which will cut this cylinder. Now the position of that plane is mentioned here. Let's see the position of plane. By a plane incline at 40 degree to the HP. So it incline at an angle 40 degree to the HP and perpendicular to the VP. So just neglect this one and bisecting the axis. It means this will cut the axis at a centrally. So its total height is 6 centimeter. So I am marking the point at a distance 3 centimeter. Draw the another horizontal reference line, small reference line. Now let's see what I am doing. Take a protractor. Now keep it over here. Now measure the angle 40 degree. So it's 0, 10, 20, 30, 40 degree. Now this is 40 degree. Now what we have to do, we have to just connect this. Okay, so this is the plane which will cut. So it is the auxiliary vertical plane, so which will cut this cylinder vertically. Now for this, what we are doing, we are dividing this circle into number of 12 equal parts. So I am just dividing this circle into 12 number of equal parts and taking the projection in upward direction. Okay, now here I divide the circle into 12 number of equal angular parts. So write the dimensions from left side: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now let's see, take the projection of all these divided parts up to this incline line, incline auxiliary vertical plane. Now mark this notations over here. So 1, it is 1 dash. Now this is the 2 and 12, so it's meeting at the line at 2 dash 12 dash, then 3 11, so 3 dash 11 dash, then 4 dash 10 dash, then 5 dash 9 dash, then 8 dash 6 dash, okay, by mistake it is 7 dash, so it is 8 dash 6 dash, and last one is the 7 dash. Now let's see here, I make the 12 number of equal parts of a circle. So similarly here I make the 12 number of equal part of this rectangle. Okay, so we can use this method also that we are already learned in a class. Now let's see what we have to do. You have to repeat these notations again over here. So this is point 1, 1 2 3 4 5 up to the 12, and last one is again 1. Okay, so all of you just keep remember this, the last point is the first point itself. Okay, now what we have to do, we have to take the horizontal projections of these points on the corresponding vertical lines. What means, let's see here, I am taking the projection of point 1 dash up to the line of 1 1. So here point 1 1, now 2 and 12 dash, so here take the projection up to the line 2, next 12 dash 3, 11 dash it's 3, and 11 dash 4 dash and 10 dash, next 4 dash 10 up to the line of 10. Similarly for 5 dash up to the 5 and 9. So here 5 9 8 and 6, so it is up to the 8, and last one is the 7 dash up to the 7. So this is, so mark all those points. Okay, as let's say this is p1 dash, this is p2 dash, p3 dash, like this. Okay, here I mark the points p1 dash, p2 dash, p3 dash, p4 dash, p5 dash, and last one up to this p12 dash, and last one is again p1 dash. Now what I am doing, I am just connecting these points by using the friend sketch. So connect those points. Now this is, make it dark, and this one dark, as this is the remaining portion in a diagram, so make it dark, this one. So this is the development of cylinder which will get cut by the vertically auxiliary plane. Now make it again dark because this is the remaining one. Okay, so this is the DLS. Thank you for watching the video.